Hi, I'm Mr. Huber, and in this video I would like to talk about problem 1D, E, and F. So let's start with cosine of 315 degrees. Okay, so quick hand sketch of a unit circle. First draw the circle and then the axis. Oftentimes that's much easier. So 90 degrees, 180 degrees, 270 degrees, and now 45 degrees more. So it's somewhat like this. This is 315 degrees. So now this is the sine and this is the cosine. This length is the cosine. Well, you don't find 315 degrees here, but you know this is now 45 degrees. So you know where the 45 degrees is. Well, it's in fact minus 45 degrees, okay? Minus 45 degrees. And well, 45 degrees for a cosine is square root of 2 over 2. Look, it's in the, not in the first, not in the second, not in the third. It's in the fourth quadrant. It's in the fourth quadrant. So this is positive. Same thing as if it had been 45 degrees. Minus 45 degrees and 45 degrees is the same thing for my cosine value, okay? Whether you're down here or up here doesn't matter for the cosine value. It does matter for the sine value, but it does not matter for the cosine value, so it's just the square root of 2 over 2. Look, cosine of 315 degrees is square root of 2 over 2. So let's do the next one. Sine of minus 60. Sine of minus 60 degrees. Let's have a unit circle here. So minus 60 degrees is probably something like this. Minus 60 degrees. So this is your sine and this is your cosine. If you had gone up here, this would have been 60 degrees, okay? Well, I have to hit that spot here. Let's try to do it in a bit better. Okay, 1, 1, minus 1, minus 1. But you're down here at minus 60 degrees. You see, for the cosine, that wouldn't make a difference. It's the cosine of 60 degrees is the same thing as the cosine of minus 60 degrees. But it does matter for the sine. Because for the sine, you're here in the fourth quadrant. So this will be negative. So it's the same thing as the sine of 60, but negative, because it's in the fourth quadrant. So sine of 60 degrees is the square root of 3 over 2. And because it's in the negative, it will be minus the square root of 3 over 2. Now, the last one, f tangent of 135. So tangent of 135. So let's have a unit circle here. This is our tangent to the circle. This is 1, 1, minus 1, minus 1. And you see it's by far not perfect, but it doesn't have to be. Now, look, 135 degrees is 90 plus 45. So here. This is 135 degrees. So this is like a 45-degree angle. And now look, the tangent doesn't hit up here, like in my explanation here. For an angle in this quadrant, you have your tangent here. But for an angle, for example, in this quadrant, in the second quadrant, you have your tangent down here. So you just continue this line. And this will be the length we're looking for, okay? Now look, it's like a 45-degree angle, but it's in the negative, okay? Look, tangent of 45 degrees is 1, but because it's in the negative, it will be minus 1, okay? it will be in one line with this minus 1 here. Look, 45 degrees, that would have been here. Okay, 45 degrees would have been here. So it would have hit somewhere up here, like this. This would have been 45 degrees. 1. Because it's 135 degrees, it's like the 45-degree angle here. So it goes down and it will be minus 1. So this length is minus 1. Let's check whether that's true. Tangent of 135 is minus 1. Hope it wasn't too difficult. See you in the next